Hi everybody, so today we're going to keep talking about inequalities, but we're going to talk about polynomial inequalities. Okay, there's two methods for solving these. Okay, and first we're going to talk about the graphical method for solving. Okay, so like the name suggests, you need the graph to solve this way. Okay, and that's actually the first step in this method, is you would graph the polynomial. Well, even before you do that, really, you want to put the polynomial in standard form. Okay, which means you would have the polynomial on the left, okay, and then on the right, you're going to have 0, okay, and then here is where your inequality is going to be. Okay, so greater than, equal to, whatever, but you have to be comparing the function to 0. Okay, then the second thing you're going to do is graph the polynomial. Okay, and then you are going to use the graph okay, to determine the solution. Okay. And then finally, you're going to write your answer, and the right notation is interval notation. Okay. Now, just for speed, I have pre-prepared the graphs, okay? But you guys could draw all of these graphs by hand. If you need a review of how to graph polynomials, that was earlier, that's in S.10. Okay, so you can review how to graph polynomials. But first, we're just going to look at some quadratic inequalities, okay? So for this one, okay, you have x squared plus 4x is greater than or equal to 0. Okay, so the method I used to graph this was I found both of the x-intercepts, and then I looked at the x value that was halfway in between them. That's the x value of the vertex, and plugged it in to get the y value of the vertex. Okay, so that gave me this graph. Okay, so here's my two x values of my vertex. Okay, or my x-intercepts, and then halfway in between them at -2 is my vertex. Okay, so here's my graph. Now I want to look at where this graph is greater than or equal to 0. Okay, so this is talking about y values that are greater than or equal to 0. Okay, you are looking for when y is greater than or equal to 0. Okay, so you guys know that's when you are above the x-axis. So the part that I pointed to right here, okay, including this point, okay, is one part of the graph that's above the x-axis, the part where the y values are positive. But you can also see this part over here, the y values are positive. Okay, so there's two different parts of the graph that satisfy this. Y is greater than or equal to 0. Okay, so we are going to write an interval describing the x values. Okay, so we are describing the x values with our answer. Okay, it's asking about when y is greater than 0, and your answer is in terms of x. Okay, so this part here, starting way off to the left at -infinity, okay, goes up to this value here, right? Remember, this part continues off to the left, so that's why we stopped at -infinity, continues to this point, which is -4. Okay, now because we have greater than or equal to, we're going to include that x-intercept. Okay. Then we're going to look here. Again, we're going to include the x-intercept that's at 0. You include it by using the brackets, right? And this continues off to the right, so we're going to go off to infinity. Okay. And because both of those are our answers, we're going to combine them with the union. Okay. Let's look at another example. Okay, so we're going to look at 9 minus x squared is greater than or equal to 0. Okay, so for this I actually use base graphs and transformations. Okay, the minus sign reflects my graph. okay, and then plus 9 moves my graph up 9, okay? So here's my graph, okay? And I want to look at where this graph is greater than 0, okay? So again, greater than 0 is going to be above the x-axis. So I'm going to be looking at this part of my graph, right? This whole part of the graph is above the x-axis. Remember, this is asking you when is y greater than 0. Okay, and your answer is going to be in terms of x values. Okay, so they're giving you the values of y greater than 0, and you're answering in terms of x. Okay, so we're going to look at the part that we just highlighted, and we're going to describe those x values, right? So we're talking about this part. The x values range from here to here, okay? So this is -3 up to +3, okay? And because this is strictly greater than, we don't want to include the x-intercepts, and we'll show that by using parentheses. Okay. All right. Let's look at some examples where the graphs are more complicated. Okay. Now, this is still a polynomial, okay? And you would do all of the things to graph this that we talked about. You would look at the end behavior, you would look at the x-intercepts, the roots and their multiplicity, okay? And after you do that, you should end up with this graph, okay? So we want to know, where is this graph greater than or equal to 0, okay? So again, greater than or equal to 0, they're talking about the y values are greater than or equal to 0. Okay, so we're going to highlight all the places where the y values are greater than or equal to 0. Here we go. Okay, and continuing on, right? Okay, so we're going to look at what x value that is. So the x values start here at -3. Okay, and because we have or equal to 0, we do want to include that point. Okay, then the x values continue, all right, and then off to infinity. All right. Okay, let's look at one more example. Now I realize these all have been greater than or equal to 0. Okay, so this one is less than 0. All right, so we have, again, you would do all the same things you would. You would look at the leading term to get the end behavior. You would look at the roots and their multiplicity to get the x-intercepts. Okay, so then you would have this graph. Okay, and we want to look at where this is less than 0. Okay, so remember, we're looking for y less than 0. Okay, so that's below the x-intercept. So that would be this point here. Okay, and there's actually no other part of the graph that's less than 0. Okay, so all of these other components are greater than 0. Okay, so we're going to look at our corresponding x values. Well, they start here at -5. Okay, and because it's strictly less than, we're not going to include that. We're going to use the parentheses. Okay, and those x values continue to 0. And again, because it's strictly less than, we're not going to include 0. Okay, all right. So that's really all there is to the graphical method. Okay, there's some appeal to this method. I think it really explains what's going on. It's really nice if you already have a graph. It's an easy way to solve an inequality, okay, or solve multiple inequalities with the same polynomial. But here, okay, if you want to solve it algebraically, okay, I think the advantages to solving algebraically are that it's usually faster, and if the x-intercepts are non-integer values, it's more accurate. Okay, so the first thing you would do is put the polynomial in standard form. Okay, this is important for both methods. Okay, you can't use this method to compare it to 0 unless it's actually compared to 0. Okay, the second thing you want to do, all right, is factor the polynomial completely. Okay. Then you're going to make a sign chart. We'll talk about what that means. Okay, and then the last thing you're going to do is write your answer in interval notation. Okay. All right, so let's look at an example. All right. Okay, so in this example, the first two steps are really done for us. We have all of our terms on the left here, right? That's what we mean by standard form. You want everything on the left and you want the right side to just be 0, okay? And then you also have this polynomial already in factored form, okay? So those parts are really done for us. So now we're going to make a sign chart. Okay, and I want to show you guys how this works. This is a really useful tool, not just for this, but also for other things. So let's look at that. Okay, so the sign chart is based on the number line. Okay, and the numbers you're going to mark on the number line are the roots. Okay, so let's look at the roots. Okay, so this would be 0, -2, 5, and 1. Okay, and those are the numbers we're going to mark here. And you do have to mark them in order, right? Just like you would on the number line. So -2, 0, 1, and 5. It's not important that they're spaced correctly. It's just important that they are put in order on the number line. Okay, and then we're going to list all of our factors up the side here. Okay, so x is one of our factors. X plus 2 is one of our factors, x minus 5, and x minus 1. Okay, and then for each factor, okay, you're going to look at these values of x and say whether the factor would be positive or negative. Okay, so if x is less than -2, for example, -3, -5, okay, then x would be negative. Okay, if x is between -2 and 0, like -1, okay, then this factor x is still negative. If x is between 0 and 1, like 1/2, then x must be positive. If x is between 1 and 5, like 2, 3, or 4, that's positive. Okay, and then when x is greater than 5, like 6, 7, 10, 100, x is still positive. Okay, so now we're done with our factor x. So now we're going to look at x minus 2. Okay, so if x is less than -2, for example, -3, you would have -3 plus 2, that's -1. So in that area, it's going to be negative. Okay, then between -2 and 0, like -1, -1 plus 2 is +1. So that would mean this factor is positive. Okay, between 0 and 1, like 1/2, we would have 1/2 plus 2, that's 2.5, that's positive. Between 1 and 5, like 2, 2 plus 2, that's 4, that's still positive. Okay, and something greater than 5, like 6, 6 plus 2 is 8, still a positive number. Okay, so you're not actually filling out the numerical values, right? You're just testing a value and then marking whether you get something positive or negative. Okay, Now if I plug in -3 for this, I'll get -3 minus 5, that's -8, that's negative. Here, -1 minus 5, that's -6, still negative. 1/2 minus 5, that's -4.5, still negative. Okay, 2 minus 5, that's -3, that's still negative. Okay, and then 6 minus 5 is 1, that's positive. Okay, you can see that these are changing sign exactly at the zero, the root or the zero that corresponds with that factor, right? So x is changing sign at 0, its corresponding root. X plus 2 is changing sign at -2, its corresponding root. X minus 5 is changing at 5, its corresponding root. Okay, so if we plug in something small like -3, -3 minus 1 is -4, that's negative. Okay, when we plug in like -1, -1 minus 1 is -2, that's negative. Something between 0 and 1, okay, 1/2 minus 1 is -1/2, so that's still negative. Okay, and then something between 1 and 5, like 2 minus 1 is +1, so this is going to be positive. Okay, and then something bigger than 5, like 6 minus 1 is 5, that's positive. Okay, you can see that this one has also changed sign at its corresponding root 1. Okay, now after we have all of that, we're going to look at the product. Okay, P for product. So negative times negative times negative times negative. Well, when you multiply 4 negatives together, you get a positive. Here we're going to have negative times negative, okay, that's positive, times positive, still positive, times negative. Okay, here we have 2 negatives, 2 positives. If we multiply those, we'll get a positive number. Here we have 3 positive numbers and a negative number, that would be negative. And here, all positive numbers, that will be positive. Okay, so this is the sign chart for the polynomial itself. This is the sign chart for each factor, okay, and this tells you the sign for the overall function. Okay, so now we're going to look back and see what we actually wanted. Okay, we want greater than or equal to 0. Okay, well, greater than or equal to 0, that's positive. So we're looking for the positive parts. Okay, so we're going to go -infinity to -2, just following off this number line, right? Out to -infinity, up to -2. And because it's or equal to, we're going to include. Okay, then we don't want this part because it's negative, it's not greater than 0. Here, 0 to 1. Okay, not this part. And then out here, 5 to infinity. Okay, and we're going to combine all of these intervals by using the union. Okay, so this would be our final answer. Let's do another example of that. Okay, so again, we're going to look at our roots. Okay, so our roots are going to be 0, -4, and -1. Okay, so we're going to make our sign chart and we're going to mark those 3 numbers in number line order. -4, -1, 0. Okay, then I'm going to list on the side the different factors. Okay, now when you have x squared, you have a choice. You can list x and then x again, or you can just list x squared. Okay, so when you have a square factor, you can just list it as a square, or you can list the factor twice. That's up to you. Okay, then I'll list my other factors, x plus 4, x plus 1. Okay, now when I plug in anything to x squared, that's going to be positive. It doesn't matter what the value of x is. X squared is a positive number. Okay, Now for x plus 4, if I plug in something less than -4, for example, -5, I'm going to get something negative. If I plug in something between -4 and -1, like -2, that'll give me something positive. Between -1 and 0, like -1/2, that'll be positive. And then something positive, like 1, still positive. Okay? And then I'm going to fill in the signs for x plus 1. So like -5, that would give me a negative. -3, that would give me a negative. -1/2, that's going to be a positive. Okay, and then something bigger like 1, 1 plus 1 is 2, that's positive still. Okay, and then I'm going to look at the product. So negative times negative is positive. Negative and 2 positives is negative, and then I have positive, positive. Okay, now let's look back at the original question to see which part I'm looking for. Okay, less than 0. Okay, that means I'm looking for the minus sign. Here's my minus sign. Okay, so it's only negative between -4 and -1. Okay, and because it's strictly less than and not less than or equal to, I'm going to use parentheses. Okay. We are going to do more examples of this, but I want to show you an example where you have to do the factoring yourself. Okay. So here's when it's important that you remember you need to move all of the terms to one side. Okay, so I'm going to do that now. Okay, you have to have all the terms on the same side. Okay, now I'm going to factor this. Oops, I changed this to x squared for no reason. Okay, this is quadratic in form. Okay, and now I'm going to look for two things that multiply to +4 and add to -5. So I think that's -4 and -1. Okay, and then this is going to factor even more because this is the difference of squares. Okay, so I have my 4 factors here. I'm going to look at my roots: -2, +2, -1, +1. Okay, and I'm going to start by marking those on my sign chart. So -2, -1, +1, +2. Okay. All right. And now I'm going to list my factors on the side. X plus 2, x minus 2, x plus 1, x minus 1. Okay? It doesn't matter what order you put the factors in. Okay? It only matters what order you put these in because this is supposed to mirror the number line. These, you can put them in any order you want. You can see I just put them in the order they're written. Okay? So over here, we're going to have something less than -2, something like -3, -5, something like that. So that'll be negative. Something between -2 and -1, like -1.5. -1.5 plus 2 is +1/2, so that's going to be positive. Okay, something between -1 and 1, like 0, that will be 2, that's positive. Okay, something between 1 and 2, like 1.5, that would be 3.5, that's positive. And something greater than 2, like 5, 5 plus 2 is 7, that's positive. Okay, by now I feel like you guys know how to fill these out, so I'm going to fill out the rest of them. I would have negative, 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 positive. Here I'm going to have negative, negative, positive, 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 and here I'll have negative, 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 positive, positive. Okay, then I'm going to look at the product. 4 negatives multiplied together is a positive. 3 negatives multiplied together is negative. 2 negatives, that's a positive. 1 negative. Okay, so here's my final sign chart: plus, minus, plus, minus, plus. Okay, now I'm going to look at the original question. What am I interested in? Less than or equal to 0. So I'm looking for the minuses because those are less than 0. Okay, so between -2 and -1. Okay, and again, because it's less than or equal to, okay, I want to include those. And here, between 1 and 2. Okay, and I'm going to include those because it's less than or equal to, and I'm going to combine them using the union. Okay, all right, let's look at one more example. Okay, now everything's already on the left, so that's a good start. Okay, and we have to factor this. Okay, so it's not quadratic in form. We have 4 terms. Okay, so 4 terms should give you a clue that we need to factor by grouping. Okay, so my first group here has x squared as a common factor. My second group has -2 as a common factor. Okay, now I have this common binomial x minus 3. I'm going to factor that out. Okay, and then I have x squared minus 2. Okay, now again, you have a choice with these x squared type of factors. You could continue to factor this as the difference of squares, x plus root 2, x minus root 2. Okay, oops. Okay, and I think that's the easiest thing to do. All right, so let's make our sign chart. Okay, so I have minus root 2 as one of my roots, positive root 2, okay, and then 3. All right, and then I'm going to list my factors, x minus 3, x plus root 2, x minus root 2. Okay, now when you're plugging things in to check here, remember that root 2 is between 1 and 2. Okay, so this is going to be negative, 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 positive. This will be negative, positive, positive, positive. Okay, and this will be negative, negative, positive, positive. Okay, and then I'm going to look at the product. 3 negatives multiplied together is negative. 2 negatives is a positive. 1 negative is a negative. Okay, and this one will be a positive. Okay, so once I have my sign chart done, then I look back at the question, greater than 0. Okay, so that means I'm looking for the plus areas. Okay, so between -2 and 2, sorry, between negative root 2 and positive root 2. Okay, and because it's strictly greater than, I'm going to use parentheses. Okay, and then this part, 3 off to infinity. Okay, and I'm going to combine those two intervals using the union. Okay, all right. So I encourage you guys to practice this. Please don't use another method. Try the sign charts. I promise it's a good way to do this, and I will see you guys soon.